Okay, so in the last class we have some doubt on the damping factor, okay, which is nothing but a zeta. Okay, so the question was how much time it will take for the amplitude to reduce by half. Okay, so we have got the equation like x2 by x1, like the displacement at time at a point of time 2 divided by displacement at a point of time 1. So x2 by x1 in this case is half. After some time, the amplitude will be reduced by half. So e to the power minus zeta into omega n into time. Time here, time initial time is t1. After a time period of capital T, it will become t1 plus t2. Okay, so x2 by x1 is this term. So how much is this? You know a by a to the power m plus n divided by a to the power m is equal to a to the power n. Because a to the power m, a to the power m cancels out and it will be a to the power n. So using the same principle, you got x2 by x1 is equal to e to the power minus zeta into omega n into capital T. Okay. So once you get this equation, you take the logarithm of this. So ln x2 by x1 is equal to minus zeta into omega n into capital T. Okay. So this term is otherwise called as logarithmic decrement. Okay. So why it will be zeta into omega n into capital T? Because you take a ln of e to the power some term is equal to that term only. Because ln e is equal to 1. So ln x2 by x1 is equal to minus zeta into omega n into t. Because ln e is equal to 1. So minus zeta into omega n into t. Okay, so now what is this zeta? This zeta is nothing but your actual damping by critical damping. Okay, normally damping they write it as C, but in your book it is written as B, and the C subscripts implies critical damping. So your damping factor is equal to B by BC. Okay, so the formula for damping factor B by BC is equal to zeta is equal to B by 2 to the power square root nk. So that means the BC is nothing but 2 square root nk. Okay. So your zeta is B divided by 2 square root nk. Okay. So that is your zeta, and zeta into omega n. Omega n is how much? Square root k by n. So when you multiply these two terms like B square root nk into k by n, so the k cancels and it becomes B by 2m. Okay. So your this term zeta into omega n is nothing but your B by 2m. Okay. So now you know ln half is equal to zeta into omega n. This whole term will become B by 2m into t. Okay. So now you can find out ln half, you know, zeta omega n you know is equal to B by 2m. Then you can find out t. So that is the time taken for the amplitude to reduce by half. Okay. And there is a general equation that you should remember. The formula for logarithmic decrement delta is equal to ln x2 by x1, which is 2 pi zeta divided by square root of 1 minus zeta square. So zeta, what is zeta? You should always remember. Zeta is equal to actual damping by critical damping, which is nothing but B is the actual damping, and the critical damping is 2 into square root mk. So zeta is equal to B by 2 into square root mk. This you should always remember. If you remember that, then everything will be simpler for you. Okay. So next class we will study about the forced vibration. So we finished free vibration. We finished free damped vibration. Next we will study about forced vibration. Okay. And so you will try to find out, solve this numerical and try to find out what is T. It is there in your book. You will try to find out and try to solve some simple numericals from your exercise or and workbook. Okay.